Okay. Is screen visible? Somebody can reply or chat. Is it visible? Okay, Abhishek, good, yes. So I think last time we have discussed about reversible process, irreversible process. Then I think we have discussed about the Carnot cycle. Am I right? Somebody can somebody can unmute and tell. Last lecture what we have discussed. One numerical also we have solved on the concept of Clausius inequality. That also we have discussed in the last lecture. Is it correct? Chat box at least mention if you want to. You don't want to share, then at least mention in chat box. Okay, so today this problem is solved. So I think this problem we not solved. Heat engine receives reversibly 420 kilojoule per cycle of heat from a source at 327 degrees Celsius and rejected heat reversibly to a sink at 27 degrees Celsius. There is no other heat transfer. Show which of the following cases cycle is irreversible, reversible, and impossible. One first case is there 220 kilojoule per cycle is rejected, 105 kilojoule per cycle is rejected, and third case is 315 kilojoule cycle per is rejected. Can you solve? Can you able to solve? Last time I think we have taken similar example of this. So Clausius inequality theorem tells us that cyclic integral of dq by t is equal to 0 when that cycle will be reversible. Cyclic integral of dq by t is less than 0 for irreversible cycle. And if cyclic integral of dq by t is greater than 0, then cycle we will call it as a impossible cycle. So accordingly, that way, in these cases are there for only heat rejected case is heat rejected quantity is different in all these three cases, but heat supplied and reservoir and source and sink temperatures are same in all three cases, and only we have to rejected heat we have to take differently in every case, and we have to calculate dq by t, cyclic integral of dq by t. This is symbol of what? Cyclic integral dq by t. Can you be able to solve? Chat box, please mention in chat box. Anybody? Chat box, nobody is interacting. Whether I am audible or not. Am I audible? interaction why measure. Yes, sir. So can you able to solve then? Prerna, Prathamesh. Say yes, sir, is for whether I am audible for that or whether you can able to solve. Are you able to solve?
Yes, sir.
Okay. So no problem. You can able to solve. So Prathamesh, I am trying to solve. Very good. So I am giving 3-4 minutes to you. If, and then I will try. If not possible for you, then I will solve. Please try to solve. Pawan Shinde is there today? Is Pawan Shinde joined today? Yes. Pawan, then are you able to solve this numerical? In last lecture, we solved this problem. We have solved this problem or another. This problem was solved in last lecture.
No, sir.
And a different problem was solved. 1130 kilojoule, that problem was solved. Another practice for you. So when you check that problem, I think last lecture we have solved. Another quantity was different. Magnitudes were different. Please check. Because we have solved the problem maybe 5 days ago. So therefore I want to revise first some things. Then we'll start our new lecture. Okay. So in this numerical, we have to calculate cyclic integral of dq by t in each and every case. And therefore, cyclic integral of dq by t, to have the cyclic integral of dq by t, So one heat engine is there. Somebody can help me to heat engine. It is reversible. Not reversible. One heat engine is there, and it is receiving heat at quantity. Let us consider that quantity as a Q1 quantity. Okay, and it is receiving that Q1 from a source at temperature T1. Let us now T1 is a source temperature and is equal to, somebody can help me, what is source temperature now? We have to go back one. If somebody is helping me, then it will save our time. Heat engine receives
600.
Okay, somebody will help. Okay, how much it is?
600.
600 degree Celsius, correct, or Kelvin?
Kelvin. Kelvin.
Directly it is coming as Kelvin. Okay, 600 Kelvin. So we have to first convert all the temperatures for this Carnot cycle numericals on, or reversible cycles numerical on Kelvin. 600 Kelvin, and how much we are receiving? 420 kilojoule per cycle.
Kilojoule.
So per cycle means it is cycle only. So it is 420 kilojoule. Okay. Then some amount of that heat will be converted into work, obviously, because it is heat engine. So W amount of work is going to be there. Then some, now depending on the source sink, now sink temperature is also fixed. What is sink temperature T2?
300 Kelvin.
Okay, it is 300 Kelvin. And with the first case we can say. Okay. And Q2 is different in all cases. Now in first case, what is Q2? Somebody can tell me.
210.
210. Now in first case, we have to calculate cyclic integral of dq by t. Cyclic means what? It is taken, integration taken over a cycle. And what cycle now is equal to what? Q1 in that cycle, heat supplied Q1 divided by temperature T1 minus, why minus, anybody? Q2 divided by T2. Cyclic integral of dq by t for a cycle is nothing but what? In this cycle, two heats are there. One is supplied and one is rejected, and accordingly two temperatures are there. So Q1 divided by T1 is positive because anybody? Q1 divided by T1 is positive because chart box you mention, or you can take, because it is heat supplied. Okay, and last one is what? Q2 divided by T2 is negative because it is heat rejected. Okay, and we have to calculate this. So how much it will be? Q1 is how much? Q1 is 420. Divided by T1 is how much? 600. Minus Q2 is 210 divided by 300. What is this answer? Anybody?
0.
0. 0 means what? Therefore, the cycle is what? The first case is anybody?
Reversible.
Reversible. Very good. First case is reversible. Okay. Now second case. What is second case? Only thing is there that instead of this 200 or 10 kilojoule, what will be the first case? 105. So in that case, only Q2 will be what? Replaced by 105. So second case, Q2 is equal to what? 105. And second case, what is cyclic integral of dq by t is coming? Again, is equal to what? Q1 divided by T1 minus Q2 divided by T2. In second case, you put the values and you calculate the cyclic integral of dq by t. What is the value? Anybody of you?
0.35.
0.35 means it is what? Greater than
0.
0. Therefore, cycle is what?
Impossible.
Impossible. Very good. And third case. What is third case? You would now tell directly third case. Third case, cyclic integral of dq by t. Same way to write. Is equal to again q1 divided by t1 minus q2 divided by t2. And it is coming as anybody?
Minus 0.35.
Minus 0.35 means cycle is what?
Irreversible.
Negative is irreversible. Reversible, impossible, and irreversible. Okay. Everybody got mentioned in chat box so that we can go to the next numerical. So it is very simple. Anybody? Nobody chatting. Nobody got from this. Nobody learned. I want everybody should be interactive. Okay, let's everybody. Okay. Yes, sir. Yes, sir. There is no one. Yes, sir. Very good. Only two. Others please reply. New numerical will go for. Okay. Another numerical. A refrigeration plant for a food store operates as a reversed Carnot heat engine cycle. The store is to be maintained at a temperature of minus 5 degrees Celsius, and heat transfer from the store to the cycle is at the rate of 5 kilowatt. If it is transferred from the cycle to the atmosphere at a temperature of 25 degrees Celsius, calculate power required to drive the plant. Can you able to solve? It is which refrigerator? Carnot refrigerator. So Carnot refrigerator, its COP depends on anybody? Temperature. And as it is a refrigerator, generally it also depends on the heat extracted divided by work done. So it is the refrigerant plant for a food operates at the reversed Carnot heat engine cycle. The store is to be maintained at a temperature of -5 degrees Celsius. So what is this -5 degrees Celsius? Anybody? So it is okay. So here I will draw. So it is a refrigerator is there. Refrigerator means what? It will consume the heat or it will produce heat. Nobody studying it. Refrigerator is what? Consuming the heat. There, oh sorry, consuming the work, not work heat. It is consuming the work. Okay, and it is taking heat from low temperature sink, and this T2 is equal to what? T2 is equal to what? What is the amount? T2 is equal to -5 plus 270, and is equal to what? Anybody? 268 Kelvin. For this Carnot cycle numericals. Okay. And how much it is taking heat? The refrigerant plant for food store as the operate reverse Carnot cycle is maintained -5 degrees Celsius, and heat transfer from the store to the cycle is 5 kilowatt. So Q2 is equal to what? 5 kilowatt. So it is 5 kilowatt means kilojoule. Kilowatt means kilojoule per second. So 5 kilowatt is transferring from store to the cycle. If it transferred from the cycle to the atmosphere at a temperature of, and this is transferred Q1, and is a T1 is equal to what? T1 is equal to 25 degrees Celsius, means what? 298 Kelvin. I'm directly writing now. So higher temperature is always source, and from this source Q1 amount of is taken. Okay, then calculate the power required to drive the cycle. So W is equal to, they asked to calculate W. Okay, now as this is a Carnot cycle, Carnot refrigerator, what is COP of Carnot refrigerator? Anybody? COP is equal to what? It's Carnot refrigerator. Is equal to COP of Carnot refrigerator is equal to, anybody? This function of what? Function of
Q1 upon QS minus Q1.
Q2. Here in this case now QL or QL divided by W. Q1 minus Q2. Am I right? Or as it is a Carnot refrigerator, Carnot engine, its efficiency or its COP is always function of what? It is functions COP of Carnot cycle depends on function of only temperatures also. Correct. So therefore temperature is what? At what temperature it is taking T2 divided by T1 minus T2. But as it is also general refrigerator, and general refrigerator is also function of what? Heat transfer. So therefore it is equal to what? Q2 divided by Q1 minus Q2 is equal to what? Q1 minus Q2. Okay, and is equal to what? Here Q2 divided by W. Because Q1 minus Q2 is equal to W, and this they asked. And therefore, what is T2? T2 is 268 divided by T1. What is T1 value? 298 minus 268, and is equal to Q2 divided by W. Q2 is what? 5 divided by W, and W we are getting in that case. Anybody? So this kind of numericals they are asking for 4 to 5 marks. W is coming as anybody? Others please reply in chat box or what. Take calculators with you. Write down the numericals on your notebook. Nobody is calculating. 260 divided by 298 minus 260 means 30. Anybody? Nobody solving. Chat box. Okay, I want one answer. So 1.786. Okay. Another is 0.559. Prerna Wankade. Prerna Wankade 0.559. Abhishek Dada 1.786. Please another who is matching. Their answers majority. Priyanka's answer to 0.559. So we'll consider it as a 0.559. How much work is required? 0.559. The unit for this or 0.56. You can say 0.56 kilowatt, because unit of this Q2 is 5 kilowatt. So therefore this is also 0.559 kilowatt. Okay, so 0.559 kilowatt is the answer. Everybody got this? Next numerical. You write down. I will give 2 minutes. Go over. I think it go over. Okay, take this numerical, or we'll go to simple numerical. This way solve. The heat engine is supplied with 250 kilojoule per second of heat at a constant fixed temperature of 227 degrees Celsius. The heat rejected at 27 degrees Celsius. The cycle is reversible. If the amount of heat rejected or calculate amount of heat rejected. In that case, instead of if we'll write here, later calculate. हा जुना आलो सर करणार. The amount of heat rejected. Write down and solve. It is reversible cycle means Carnot cycle, because Carnot cycle is only a reversible heat engine cycle. So another way is there that for reversible cycle, cyclic integral of dq by t is equal to 0. That is q1 divided by t1 minus q2 divided by t2 is equal to 0. And we know q1, we know t1. Okay. Q1 is equal to 255 kilowatt. T1 is equal to 227 plus 273, that is 500 Kelvin. Okay, and the Q2 is equal to 27 with 300 Kelvin, and T2 at 500. Or that way also we can go for, that is C heat engine efficiency, Carnot heat engine efficiency function of only temperatures. Okay, that is equal to T1 minus T2 divided by T1. Okay, is equal to Q1 minus Q2 divided by Q1. Okay, or in that case we have to calculate Q1 minus Q2 divided by Q2 is unknown, Q1, Q2, T2, Q1, T1 we are knowing. Or simple cyclic reversible cycle, cyclic integral of dq by t is equal to 0. That is Q1 divided by T1 minus Q2 divided by T2 is equal to 0. Therefore Q2 is coming as 150 kilowatt. Understood? The Q1 value we can put as a 250 divided by T1 is 500 minus Q2 we are not knowing T2, but T2 is minus 300. Sorry, 300 is equal to 0, and here in that case Q2 can be calculated. Understood? In mention in chat box. Mention in chat box. Today I think nobody is interacting. Why? It is afternoon lecture. Okay. Understood. Okay. Abhishek Zadav also understood. Very good. Understood. Written. You write down now understood and written. Write down all these numericals in your notebook. It is a practice numericals. Written also. Okay. Then shall we go for next numerical? Before that, we'll go to simple numerical. So Carnot theorem one is that also we have stated all last time. That is, if reversible and irreversible two cycles are working in between same temperature limits, that is, if their source temperature and sink temperature is same, then efficiency of reversibility engine cycle is greater than efficiency of reversible cycle, or work done from reversible cycle is greater than work done from irreversible cycle. Here they have considered HEA, B and HEB are reversibility engine cycle. Any of HEB baby, any reversibility engine, HEA reversible, and HEB is more than HEA. Okay, HEA they have considered as a here irreversible. HEB they have considered as a here reversible. So therefore, if it WB finally what we will get? So here eta B greater than eta A. This cycle you can solve. The Carnot heat engine receives 500 kilojoule of heat per cycle from a high temperature heat reservoir at 652 degrees Celsius and rejects it to a low temperature source reservoir at 30 degrees Celsius. The thermal efficiency of this Carnot heat engine is determined, and the amount of heat rejected to the low temperature heat reservoir. And they have given that Carnot heat engine receives. Now I want that everybody should be involved in this. Everybody know the formula. Reversible heat engine efficiency is greater than always irreversible heat engine efficiency. How to identify if cycle is irreversible or impossible? So by finding out cyclic integral of dq by t, and if cyclic integral of dq by t is equal to, if the ones here only one sink and only one source is there, then cyclic integral of dq by t is equal to q1 divided by t1 minus q2 divided by t2. Or Carnot cycle efficiency is also function of temperatures. All heat engines are function of heat interaction, but Carnot is a special heat engine which is function of heat as well as temperature interaction. Find out. I will give 5 minutes. Are you able to solve? Please mention in chat box, or otherwise I will solve. Are you able to solve? All formulas are given to you. Only two formulas only we have to use. Anybody of you? Chat box at least mention that we are able to solve, or you solve, sir. Not understanding that way. Mention in chat box, or you we are able to, I'm solving like one solving, sir. Okay, sir. Okay. Others please reply so that I can get confidence, or I have to prepare my mindset that I have to solve. After solving, mention your answer. I think nobody is giving answers, so I have to solve. Here, Carnot heat engine receiving, so it is a Carnot heat engine, so therefore we can say it as a HE Carnot also. Carnot or heat engine is a reversible heat engine cycle. I can, in short, I will write it as a, because Carnot is a reversible heat engine cycle. Okay. So it is receiving 500. So it is receiving 500. What is given? 500 is receiving means what? From source it is receiving. So how much? What is 500? Q1 is equal to 500 500. Okay. It's like from high temperature source and reservoir T1 is equal to. Now you tell me value 652 plus 273. Direct tell me in Kelvin. I don't have that much space. 655 plus 270. Somebody can tell chart or mention some chart. 273 plus 550 to 925 kilowatt. 925, and it is rejecting heat to T1, sorry, T2 at 30. T2 is 30 degree means it will be 303 Kelvin. 273 plus 30 is 303 Kelvin. And here only this much information is there. So it is refrigerator means it is Carnot heat engine is there. Therefore, it will develop some amount of work, that is W. This is the given data we have represented pictorially. And thermal efficiency. So thermal efficiency of any heat engine, Carnot heat engine, is a function of what? Function of reversible cycle heat engine is function of temperatures also, temperature only. So therefore it is what? T1 minus T2, formula everybody have to remember, divided by T1. What? Mention 925 minus 303 divided by. Value. Anybody point something? Mention in chat box at least. 60%, 0.6. Anybody of you, chat box or unmute yourself and tell the answer. at least one answer. 0.672. 0.672. Okay, so we'll answer the one also. What answer? 0.67. 0.67. So they asked this, and the amount of heat range, that is Q2 also asked. So Q2 also the heat efficiency is function of heat interactions. This is all heat engine, or this is also equal to what? Heat engine efficiency of any heat engine, not reversible or Carnot. Is always function of heat ratios. What is that? Work obtained, that is W. W means Q2 here. Q1 minus Q2. It is work obtained, output divided by input, and divided by input is heat supplied Q1. So is equal to 0.67. Is it possible? Okay. Therefore, Q1 is 500, Q2 that we have to calculate, and this is no not Q2, it is Q1. Huh? Q1 minus Q2 divided by Q1. So it is 0.67. Q1 is 925, Q1 is 925, or Q2 you can determine. What is Q2 value in that case? How much it is rejected it? Chart box. Mention chat box answer and then write down the numerical and solution also. I'll give 2 minutes. When I somebody got answer. So 164 months. Very good. Before going to next numerical, write down this all question as well as this numerical answer. I will give 2 or 3 minutes to you. After that, tell me that, or in chat box mention that over. Okay, it might go over. Now, this is a reversible engine receives heat from two constant temperature sources at 870 Kelvin and 580 Kelvin. It is reversible heat engine. Therefore, its cyclic integral of dq by t is equal to 0. It rejects 300 kilojoule per minute to a sink at 290 Kelvin. Means this is a three constant temperature reservoir problem. Up till now, only we are dealing with what? Only two. One is only one source and only one sink. But here in this numerical, it is two constant sources are supplying heat and they are supplying to only one reservoir sink. And engine develops 85 kilowatt. Determine heat supplied by each source and efficiency of heat engine. Okay, can you able to solve? I think not. It is asking in the examination May 2013, December 2014, and December 2018. So reversible heat engine, only one reversible heat engine is there. It is what we have to go for, only one reversible heat engine. But is it HER? HER means heat engine, but what is which kind of heat engine? Heat engine is what? Reversible heat engine. Okay. And it is receiving heat from two constant temperature sources. So let us consider this as a T1 as a one constant temperature source. So already thanks to the papers, they have given evaluation values in Kelvin. T1 is equal to 870 to 870 Kelvin. Okay, at the same time and 580 Kelvin. So there are two temperature sources. So one is what? 580 Kelvin. 580 Kelvin. So these are sources. From them, this heat engine is taking the heat. 580 Kelvin. Okay, and from this, it rejects now. It is heat engine, therefore it will what? Take you the heat. Let us consider this as a Q1 heat. It is taking from the reservoir at T1 temperature. T1 also it is taking heat. It is Q2 amount. It is taking. Okay. And it is rejecting heat to a. Now this heat engine commonly it is rejecting to another third reservoir that is called a sink. इथं आपल्याला T1 T2 ला आपण सोर्स म्हणजे इथं काय सिंक काय झाला आपला T3 झाला. व्हॉट इज द टेम्परेचर 290 केल्विन. 290 Kelvin. And here it is what? Q3 amount. Let us केला सिंगल रिजेक्ट केली हिट किती Q3 आणि किती येते 300,000 किलोजूल पर minute. पण आपण per minute whether we are taking anywhere, this is what per second. किलोवॅट जर करायचं तर काय लागेल आपल्याला कोण सांगते? Am I audible? काय कळलं नाही मला. Nobody is replying. काय करावं लागेल किलो जूल पर सेकंड करायचं तर एनीबडी काय करावं लागेल? एनीबडी ऑफ यू 3000 kilojoule per second means 1 minute is equal to how many seconds?
60 seconds.
गुड. जागेत राहत का सगळे आज? व्हॉट हाऊ मच इट विल बी? 6 30 व्हॉट 50 किलो जूल पर सेकंड, म्हणजे याला आपण काय म्हणू शकतो? किलो वॅट. ओके, किलो वॅट एवढी हिट आणि हिट क्यूब. मग हे काय म्हणते? द हिट इंजिन डेव्हलप्स 85 किलो, आणि ह्यामध्ये हे कुठं डेव्हलप करते हिट इंजिन, म्हणजे 85 किलो वॅट इज व्हॉट डेव्हलपिंग. डब्ल्यू. आता इथं आपल्याला काय झालं? इथे एरो खाली नसल्यामुळे आपण काय केले? एरो आउटसाइड दिले. डब्ल्यू इज इक्वल टू 85 किलोवॅट. and determine heat supplied by heat engine, म्हणजे Q1 Q2 काढायचं आपल्याला. where to determine and efficiency of heat engine. Understood this figure? Please mention chat box. If you will mention, then I will proceed. Anybody chat box understood? At least write down the numerical and this here up to this, and mention in chat box that understood. If not understand, I am there to repeat again. Request me to repeat if you are not understanding. In chat box mention, or you unmute and tell sir understand. Do at least one option, at least chat box, or nobody is chatting. Okay, one reply. What? Now I understand. Okay, others please reply. Arjun Angoli understood. Okay, good. Here write down, and here, so that next procedure I will take. Next we'll go for the equation solving. Very simple. It is 3 reservoir problem. You can see it is 2 source and 1 sink. Over. Now, as it is heat engine is reversible, therefore what we can say? For reversible heat engine, we can say what is our case is there for reversible heat engine. For reversible, I will write short heat engine. What will tell according to Clausius inequality? What is that? Anybody of you please chat or mention, unmute and tell. What is for reversibility engine according to Clausius inequality? Pass the cyclic integral of dq by t is equal to काय? What is value? Cyclic integral of dq by t for reversibility engine is equal to what is problem? I don't know everybody, nobody is replying. काय? Equal to 0. Okay, but आता सायक्लिक इंटिग्रल किती सोर्स आहेत? 3, म्हणजे Q1 Q2 Q3, आणि त्याचे टेम्परेचर T1 T2 T3. इथे काय येणार? आपला Q1 सप्लाइंग करतोय, म्हणून Q1 डिवाइडेड बाय T1 another plus Q2 divided by T2. ओके, आता इथं प्लस का मायनस सांगा बरं? बघू ऍटलिस्ट मायनस और प्लस घाबरताय काय Q3 कार हीट इंजिन कुठे रिजेक्ट करणार कुठल्या सोर्सला आता 3 ला म्हणून इथं ही दोन सप्लायर आहेत सप्लाय केलेली हीट नेहमी पॉझिटिव्ह आणि Q3 डिवाइड बाय T3 आता ह्याच्यावरून आपली इज इक्वल टू काय असणार आहे 0 put therefore put the values Q1 what is the value of Q1 we are not knowing Q2 we are not knowing but T1 870 Q2 580 so it is Q1 we are not knowing 1 divided by 870 Kelvin plus Q2 that is we are not knowing it is 580 minus Q3 is how much we have calculated 50 kilowatt work obtained is what here Q 50 kilowatt okay so 50 kilowatt is equal to 50 divided by 290 am I right equal to 0 let us multiply by 290 to all sides therefore what will be there okay 290 will multiply on every side therefore Q1 multiply केलं तर काय येते Q1 divided by multiplication 290 दोन्ही साइडला 290 मल्टिप्लाय करायचं जे डिवाइड बाय 3 29 सपोर्ट 29 29 ओके प्लस डिवाइड बाय 2 इज इक्वल टू हे 50 इकडे आपण ट्रान्सफर केलं तर काय होईल 290 ने मल्टिप्लाय केलं तर फक्त 50 राहील इट विल बी 50 और काय येणार व्हॅल्यू 2Q1 plus 3Q2 is equal to the MC 3 into 6 6 into 50 and is equal to therefore 2Q1 plus 3Q2 is equal to 300. Let us give this question as equation number 1. Up till now understand, please mention in the chat box. If 4 to 5 you are mentioning, then I will post it. Write down and write down also. Understood or not, mention in chat box. Am I audible, na? Nobody is mentioning in chat box. Chat box or if I want to repeat. Mention in chat box. Nobody's understanding. Am I audible? Am I audible?
Yes, sir.
Understood? Understood this equation? How you got equation? Okay.
Yes, sir.
Okay. Understand and understand. They mention in chat box. I am waiting to that. Huh? Okay, this is one equation. Another equation is there by first law of thermodynamics. So this is our, I am right going for second step. I conclude that this is here understood by you. So by first law of thermodynamics, what is that first law of thermodynamics? By first law of thermodynamics. First law of thermodynamics. First law of thermodynamics. What is that? Incoming is equal to outgoing. इनकम म्हणजे काय, जेवढं जेवढं इकडे हिट इंजिन रिसिव्ह होते तेवढं सगळं आउटगोईंग ला इक्वल असते बाय फर्स्ट लॉ ऑफ थर्मोडायनामिक्स, बिकॉज हीट अँड वर्क आर इंटर कन्व्हर्टेबल. म्हणजे जेवढी हीट येते किंवा वर्क येते त्याची हीट इंटरॅक्शन आर इक्वल. म्हणजे जेवढं आउटगोईंग इनकमिंगला आहे तेवढं आउटगोईंगला. इथे इनकमिंगला काय Q1 आणि Q2, आउटगोईंगला काय W आणि Q3. इथे इनकमिंगला काय Q1 इनकमिंग, Q2 इनकमिंग, outgoing मला काय असते, here it will be Q1 and Q3. So Q1 plus Q2 is equal to Q3 plus W. Am I right? So Q1 plus Q2, they are coming incoming. So therefore Q1 plus Q2 is equal to here Q3 plus W. Q1, how much Q1 is there? Q1 is how much? We are not knowing. Q3 किती आहे? 50. W how much? 85. हे आपण दिलेलं आहे त्याच्यामध्ये. ओके, therefore Q1 plus Q2 is equal to काय ते 135. Is equation number 2. Understood? Mention in chat box. And now we have to solve equation 1 and 2, and we have to get the values of Q1 and Q2. Now after getting the value of Q1 and Q2, this will be heat supplied. Okay, and efficiency rejected also we know. Work done also we are knowing. So Q1 plus Q2 is equal to 135 is our next equation. The heat supplied, total heat supplied. Now solve equation 1 and 2. Multiply this equation by latest 2. Therefore, I'm not writing the step multiply by 2. 2Q1 plus 2Q2 is equal to 270. Okay. Now this is equation, now this, and subtract it from equation 1. Okay, therefore this will be minus, this will be minus. So here it will be 3Q2 minus 2Q2 is equal to 30. Therefore Q2 is equal to 30 kilowatt. Q1 plus Q2 is equal to 135. Therefore, Q1 is equal to anybody to solve 105. What they asked, whether two answers we got. Determine the heat supplied by heat engine to Q1 and Q2 and efficiency of heat engine. Now efficiency is equal to, what is efficiency formula? Total heat supplied. Okay, sorry, work obtained. Efficiency eta heat engine is equal to what? Work obtained divided by, आता इथं काय करायचं, heat supplied ऐवजी इथे काय करायचं, total heat supplied. Total heat HS. I am writing heat supplied. How much it is coming now? Is equal to W किती आहे आपला 85 and total heat supplied किती येते Q1 30 Q2 135 घेतलं इक्वेशन नंबर 135. How much it is coming? Point मध्ये लिहा किंवा पर्सेंट मध्ये लिहा. How much it is coming? At least tell that thing. तेवढं जर सांगा. Anybody of you? Chat box, mention in chat box answer as well as understood and write down. Mention in chat box. Take chat I got 0.69 and understood. Return that also you write down. Q1 is equal to 105. This is late answer. Q1 already we got. Okay. Okay. 0.69 answer is what required. 0.69 or 69%. If you want to write in percentage, multiplied by 100, 69%. Understood and written. Please tell. Right and understand. If it is no, you are not understanding, ask me to repeat. I think I want 4 to 5 chat, then we'll proceed for next numerical. Okay, one chat at least. Understand. Okay, Vaibhav, Solana, others please reply and write down return. Return now understand. I will give 2 minutes to you. I will give 2 minutes to you. Okay, I will provide. I think the study material is there, but still I will provide. Okay, this numerical you solve. The Carnot heating, write down. This is asked for 7 March April 2016. A Carnot engine works between temperature limit of 825 and 125. The engine receives 300 kilojoule of heat per minute. Determine power of engine and amount of heat rejected per second. So write down the numerical. Write down. Try to understand. If you are not understanding, please ask me. Everything is given. Okay, so I'll repeat. Carnot heat engine is there. Okay, works between two temperature limits. So T1 is there 825, 825 plus 273 is equal to 1098 Kelvin. And another is sink, that is low temperature sink. T2 is equal to here T2 is equal to 125 plus 273, it is 398 Kelvin. Okay, then here these two temperature they are given. As it is heat engine, it is developing the work W. Okay, then the engine receiving means supply, getting, supplying, taking Q1 amount of it, 3600 kilojoule of it per minute. Per minute means what? Divided by 60 seconds. So therefore kilojoule per second means kilowatt. Therefore it is 60 kilowatt. Q2 we have to calculate. So determine power of engine. Power of engine is W, we have to find out in kilowatt, and amount of heat rejected to sink per second. Q2 we have to find out. What will be equation now? First of all, efficiency of heat engine is function of temperature because it is Carnot heat engine. It is function of temperature because it is Carnot heat engine. As well as it is also function of what? Heat interactions. So therefore, T1 minus T2 divided by T1 is equal to 1098 minus 390 divided by 1098 is equal to 0.637. Or this is also equal to what? This is also equal to what? Therefore, Q1, or it is cyclic integral Q1 cyclic integral of dq divided by t is equal to 0. Q1 divided by t1 minus q2 divided by t2 is equal to 0. And from that we can determine q2, or this is here असं ह्याच्याप्रमाणे करू शकता q1 minus q2 divided by q1 or q1. Okay, किंवा इथं मगाशी सांगितलं मगाशी याच्यामध्ये efficiency is equal to W, output divided by Q1. W is equal to 0.37 into 60 is equal to 8.25 kilowatt. हे काय झालं, वर्क झालं. आणि डिटरमाइन पॉवर ऑफ इंजिन आणि अमाऊंट ऑफ हिट रिजेक्टेड इज Q2 काढायचं तर मग नंतर हेच इक्वेशन काढावं लागलं आपल्याला. कुठलं? W इज इक्वल टू Q1 मायनस Q2 म्हणजे 60 मायनस 30 60 मायनस W किती आला 38 तर 22 25 22 किलोवॅट एवढं येईल. और करू आपण म्हटलं वाटल्यास Q2 ठीक है, you assume it is Q2 is equal to equal to 0.637. Q1 value you put as a 60 minus Q2 or is equal to, therefore 60 minus Q2 divided by 60 is equal to 0.63, and this will implies Q2 is equal to 22 just plus by 3, and this is Q2, and engine efficiency is 0.637 is equal to W divided by Q1. W is equal to 0.637 into 60, 38.25. Understand? Please mention in chat box, or you want to repeat, ask me to repeat. Please mention in chat box or unmute and tell. Today I am getting less response from you all. This problem I told. There is no derivation. This thing. Chat box, please mention in chat box. Understood. So to understand. Okay. Good. Written. Written also Abhishek. Good. Written, understand, written. 1 hour, 1 minute. I will give, still I will give 1 more minute to you. Half minute for this and afterwards half minute for next lecture. Okay. 38.25 kilowatt is the power of the heating, Carnot heating. Another engine, a domestic refrigerator maintains -8 degrees Celsius when the atmosphere air temperature is 27 degrees Celsius. Assume the leakage of a 7.5 kilojoule per minute from outside the refrigerator. Determine power required to run this refrigerator. Consider refrigerator as a Carnot refrigerator. A Carnot refrigerator, here heat to be removed continuously from refrigerator space shall be 7.25 kilojoule. म्हणजे एवढी इथं जर ॲटमॉस्फिअरचं टेम्परेचर 27 डिग्री सेल्सिअस ठेवायचं आहे, तिथे जर आपल्याला हीट रिजेक्ट करायची असेल आणि इथं आपल्याला 7.-8 डिग्री सेल्सिअस जर रेफ्रिजरेटरचं टेम्परेचर ठेवायचं असेल तर 7.5 किलो जूल पर मिनिट एवढी हीट आपल्याला काय करावं लागेल, सारखी ॲब्सॉर्ब करावं लागेल. त्यामुळे रेफ्रिजरेटरला वर्क लागेल आणि इट इज Q1. आता आपल्या भाषेत आपण नॉमेनक्लेचर दिलं तर what will be there? It will be T1. This will be T1. Let us consider this is T1. आपल्यासारखे T1 ह्याला आपण Q1 म्हणू आणि ह्याला आपण काय म्हणू, Q2. आपण ह्याला म्हणू T2. ओके, so T1 is equal to काय येणार इथं केल्विन मध्ये किती येणार 300 केल्विन. -8 म्हणजे काय 265 केल्विन. आता इथं कसं आहे आपलं here efficiency of this is a refrigerator COP shall be equal to what? COP is equal to, here we can write COP is equal to function of temperature as well as function of heat interaction. म्हणजे काय ऍब्सॉर्ब केलेली हीट म्हणतो आपण त्याला, काय म्हणतो COP ऑफ एअर आउटपुट डिवाइड बाय इनपुट. आउटपुट काय Q2 डिवाइडेड बाय W is equal function of temperatures. म्हणजे काय T2 small T2 265 डिवाइड डब्ल्यू म्हणजे Q1 मायनस Q2 याचा काय असतो 300 minus 265. आता 7.5 kilojule per minute. Q2 is equal to what? 7.5 kilojule per minute म्हणजेच किलोवॅट काढायचं आपल्याला डिवाइड बाय 60 and is equal to काय it will be 0.125. मग काढा आता W where Q2 where knowing W they asked determine power required, so W is equal to what सगळं माहिती आहे इथे QW माहित नाही फक्त 0.0165 kilo. What it understand, please mention in chat box. Return and understand, please mention. Understand, understood and written. Very good. Abhishek Jadhav. Others please reply. Yes, Rahul Salkar. Yes, Arjun understood. Yes, you solve. Determine heat to be supplied to a Carnot engine operating between 400 degrees Celsius and 15 degrees Celsius and producing 200 kilojoule of work. So T1 you mention it as 400 degrees Celsius means in Kelvin. Try to solve at own first and then afterwards take reference. So Q1 divided by T1 means Q1 or our relation is what? It is heat engine Q1 minus Q2. त्याला आपण काय म्हणतोय cyclic integral of dq by t. Q1 divided by T1 is equal to Q2 divided by T2 or T1. हे इक्वेशन चालू शकते T1 minus T2 किंवा हे both are same. Therefore Q1 T here it will be 673. आपण आजच कन्वर्ट करून घ्यायचं कारण आपले विसरते पहिल्यांदा कन्वर्ट करून घ्यायचं आणि किती 288. तर Q1 Q2 माहित आहे 200 किलो W म्हणजे आपली इफिशियन्सी काय Q1 मायनस Q2 हे W असतं W or therefore W divided by Q1 is equal to T1 किती 673 minus 288. divided by Q1 is again here. Q1 is hello. बोला की. ऐक का? हा हा. बरं. हा हा हा. बरोबर. हा. किती का तुमच्याकडे चाललं? बरं बरं. त्याची 4 नोटीस तयार केली का? समाधान आहेत का? समाधान आहेत का? मग आलं ना का? ठीक आहे, मी येतो खाली. मग लेक्चर बघा माझं 3 वाजता संपतो. येतो मग 3:15. Divided by Q1 where not Q1. Sorry, divided by T1. So it will be 673. And here unknown is only Q1. So Q1 we can find out. Q1 is equal to coming as 349.6 kilojoule. तेवढं येते. जर त्या पद्धतीने केलं आणि ह्या पद्धतीने केलं तरी तेवढंच येते. ओके. हे dq by t, cyclic integral of dq by t is equal to 0. And Q1 divided by T1 minus Q2 divided by T2 is equal to 0. म्हणजे हीट इंटरॅक्शन सगळं एकत्र करून त्याचा जर आपण लास्ट स्टेप घेतला तर हे देते. मला W ह्याच्यामधल्या 2चा फरक आहे. Q1 minus Q2 is equal to W. म्हणजे Q2 काय असणार आपलं 149 वजा 200 149.6. काय विचारले? Heat to be supplied. Heat to be supplied किती and rejected. Okay, दोन्ही काढले आपण. Answer is what? 349 rejected, 149. Pointer. Understand and write return. Please write, and then this will be the last. This is the last numerical of today's lecture. Understand and return. You mention 4 to 5 chat it will get. Then I will close the lecture. Today's lecture. Abhishek also understand return. Others please reply. Others please reply. Mention your attendance in chat box. I think, but I want good interaction. So today I am not that much satisfied. Anybody want to repeat, etc.? Tomorrow I am going to take an important chapter, that is entropy and numericals on entropy.
सर नोट्स अपलोड केलेत का?
आज करतो आज. ते आपल्या ह्याला दिलेत ना, आपल्या सरांनी, आपल्या सोळगे सरांनी अपलोड केलेत ना, स्टडी मटेरियलची लिंक दिली ना.
सर तिथे एकच व्हिडिओ अपलोड आहे तुमचा.
आय विल चेक टुडे. आज किंवा उद्या मी पण अपलोड करतो. हा.